This is Algebra 1A 5.6 line of best fit. I have the vocab on the sheet for you. So the vocab says scatter plot. It's a graph used to determine whether there's a relationship. Now scatter plot is done on an X and Y axis. And it'll just have points. And sometimes those points will have a correlation. Sometimes they won't. A correlation is the relationship between two data sets. And it can have a positive correlation or it can have a negative correlation. And line of fit, I like to put line of best fit, is a model used to represent a trend in the data showing a positive or negative correlation. So if we look at example 1, you can see that these points kind of go down in a line like this. You could kind of have a line of best fit. So they would have a negative slope, so it would be a negative correlation. Over here in example B, the lines don't really come up with a true line of best fit, so this one would have no correlation at all. Then you have to graph the correlation. So we have an X and Y axis, and we're just going to plot the points. So this is a point, 1, 3, and we're going to plot it, 1, 3, and you're just going to put a dot. And then you're going to put 1.5 and 1. So 1.5 and 1. Then you're going to plot the point 2, 1. So 2, 1. Sometimes they're right beside each other. Then you're going to plot the point 2 and negative 0.5. So 2 and negative 0.5. And then you're going to plot the point 3 and negative 1. 3 and negative 1. Then we're going to get 3.5 and negative 0.5. So 1, 2, 3.5 and negative 0.5. There we are. And last you're going to plot 4 and negative 2. So 1, 2, 3, 4 and negative 2. And you can see that this generally has a line that goes like this. So this has a negative correlation. Now some of you are saying, Mrs. Shychuk, I don't know what that means. Well, this is what you have to remember, that we have graphs, right? And when we have graphs, and I'm going to make 4 of them, these are just X and Y axes, we had learned slope. This is a positive slope. This is a negative slope. And slope goes with correlation, goes in the same trend. So back here, this was negative slope, so it's a negative correlation. We had 0 slope, and then we had undefined. So those are your slopes, and you need to know what they are because they go hand in hand with correlation. Now, we're going to plot these, but here's the thing. Do you see how it says 65, 78, 80, 86? So we're going to count by tens on the y-axis. And on the x-axis, count by ones. All right, we'll see. So 165. So 1, 10, 20, 30, 40, 65. There we go. Then we have 276. So 1, 2, 10, 20, 30, 40, 50, 60, 76. I don't know. I think it might be wrong. Let me count again. 2, 1, 2, 3, 4, 5, 6. Maybe the first one's wrong. Let's start over. First one. 1, 1, 2, 3, 4, 5, 6.5. Okay. And 2, 1, 2, 3, 4, 5, 6, 7. There we go. Then we have 382, which is over 3 and up to 82. And then we have 486, which is over 1, 2, 3, 4, and up just a little bit more. Then we have 592, so 592. And then we have 697, because they're ordered paired, so 697. So we're here. It says write an equation that models y as a function of x. Use the data. Well, we had to plot it, and we have this as our line. It has a positive line. So I'm going to use the first point and the last point. One, I'm going to find slope. So it's going to be, now again, we're using the first point and the last point. So we're going to say 97 minus 65 over 6 minus 5. Get your calculator out because you're going to need it. 97 minus 65. So that gives you 32 over 6, not 6 minus 5, 6 minus 1. Sorry, I'm putting the wrong point. 6 minus 1. So over 5. So roughly, you're going to have a slope of 6.4. All right. Then you're going to use all those fun equations and pick a point, any point you want for funsies. Let's just pick a middle point. So we're picking the point I started. And you're going to say y minus 82 equals 6.4, which is slope, times x minus 3. And you're going to solve that. So y minus 82 equals 6.4x. And then we're going to have 3 times 6.4, which gives me a negative 19.2. I'm going to add over the 82. So we're going to make that negative and add 82. And you're going to get y equals 6.4x plus 62.8. So you see, let's see, 10, 20, 30, 40, 50, 62. Look, that's about dead on where my y-intercept is. All right, write an equation to model this, it says. So you have to plot it. Let's see if we can find another way. So years since 2000. So we have years since 2000. 0, 1, 2, 3, 4, 5, 6. Those are years since 2000. So we're at 0, and then we're at 488, which is roughly here. We're at 1 and 497, a little bit higher. We're at 2 and 525, which is right in the middle. We're at 3 and 567, so that's up here. We're at 4 and 583, which is up there. We're at 5 and 621, and then we're at 6 and 688. So that's what our line looks like, roughly. And we know that our line of best fit looks something like this. Something like this. Again, you can use the first point, which is 0, 488, and the last point, which is 6 and 688, and find your slope. So 688 minus 488 all over 6 minus 0 gives you 200 over 6, and you're going to divide. What is 200 divided by 6? It's like 33.3. There's your slope. Pick a point, any point. So, I don't know, I'm just going to pick the one I boxed. And the point is 3 and 567. So you say y minus 567 equals 33.3 times x minus 3. Get your calculator. 33.3 times x. And then 3 times 33.3. Look, 99.9. Bring down the y minus 567. Add 567 to both sides. And you are coming up with y equals 33.3x plus 467.1. Which is about right, because that's about 467.1. Pretty good. Pretty good. Last but not least is make a scatter plot and describe the correlation. So here you just plot the data. 1, 5. And then 2, 5. And then 2, 6. And then 3, 7. And then 4, 8. And then 5, 8. And it roughly looks like this, and it's a positive correlation. Because it looks like a positive line when we graph it. And your homework. So homework is page 328, 329, numbers 1 to 15. You may need graph paper, it's in the bin. See you on Monday.